Hello friends, in the last video we have seen how Buchholz relay used for the protection of transformers. But there are certain limitations of Buchholz relay due to which we have to use differential protection for transformers. The Buchholz relay can detect faults occurring within the transformer's insulating oil. It fails to detect faults that do not involve the oil. Buchholz relays do not adequately cover flashovers at the bushings. But differential relays can detect these type of faults. Although Buchholz relays detect internal faults in transformers, differential protection schemes do the same thing but more quickly. The transformer is one of the major equipment in power system. It is a static device, totally enclosed and usually oil immersed, and therefore the fault occurs on them are usually rare. But the effect of even a rare fault may be very serious for a power transformer. Hence, the protection of power transformer against fault is very important. The fault occurs on the transformer is mainly divided into two types: external faults and internal faults. External fault is cleared by the relay system outside the transformer within the shortest possible time in order to avoid any damage to the transformer. The protection for internal fault in such type of transformer is to be provided by using differential protection system. Differential protection schemes are mainly used for protection against phase-to-phase fault and phase-to-earth fault. The differential protection used for power transformers is based on Merz-Prize circulating current principle. Such type of protection are generally used for transformers of rating exceeding 5 MVA. First, we will see the basic principle of differential protection. The relay whose operation depends on the phase difference of two or more electrical quantities is known as differential protection relay. It works on the principle of comparison between the phase angle and the magnitude of the same electrical quantities. The differential protection relay is used for the protection of generator, transformers, feeder, large motors, bus bars, etc. There are basically two types of differential protection relay: current differential relay and biased or percentage differential relay. A relay which sends and operates when there is difference between the current entering into the electrical system and the current leaving the electrical system is called as a current differential relay. Here you can see an arrangement of overcurrent relay connected to operate as differential relay. The dotted line shows the section which is used to be protected. The current transformer is placed at both ends of the protection zone. The secondary of the current transformer is connected in series with the help of pilot wires. Thereby, the current induces in the CTs flows in the same direction. The operating coil of the relay is connected on the secondary side of the CTs. In the normal operating condition or external fault condition, the magnitude of current in the secondary of the CTs remains same. Therefore, zero current flows through the operating coil. On the occurrence of the fault, the magnitude of the current on the secondary of the CTs becomes unequal, due to which the relay starts operating. This is called as Merz-Prize circulating current principle. For example, in case of internal faults, if the current flows to the fault from both sides, the sum of the CT secondary currents will flow through the differential relay. It is not necessary that fault current flows to the fault from both sides to cause secondary current flows to the differential relay. That means we can say that the differential relay current will be proportional to the phasor difference between the currents entering and leaving the protected element. And if the differential current exceeds the set value of the relay will operate. Percentage differential relay is the advanced form of differential protection relay. The only difference is that this system consists an additional restraining coil connected in the pilot wires. The current induced in both the cities flows through the restraining coil. The operating coil places between the midpoint of the restraining coil. The restraining coil prevents the relay from tripping during normal operation or external faults. The restraining coil also helps to prevent the relay from tripping due to inrush current when a transformer starts up, as these currents can be very large. This is the most used form of differential relay. The torque due to the restraining coil prevents the closing of the trip circuit, while the torque due to the operating coil tends to close the trip circuit contacts. Under normal operating conditions or external fault condition, the torque developed by the restraining coil is greater than the operating coil torque. Thus, the relay remains inoperative. When an internal fault occurs, the operating torque exceeds the restraining torque. Then the trip circuit contacts are closed to open the circuit breakers. The differential current in the operating coil is proportional to I1 minus I2. And differential current in the restraining coil is proportional to I1 minus I2 divided by 2. Because the operating coil is connected to the midpoint of the restraining coil. For external faults, both I1 and I2 increases and thereby the restraining torque increase, which prevents the maloperation of the relay. Now we will see connection for differential protection for transformer. The power transformer is star connected on one side and delta connected on the other side. The cities on the star connected side are delta connected and the cities on delta connected side are star connected. The neutral of the CT star connection and power transformer star connection are grounded. The restraining coil is connected between the secondary winding of the CT. The operating coil is placed between the tapping point of the restraining coil and the star point of the CT secondary winding. The secondaries of both CTs should be connected to the operating coil of a differential relay in such a manner that there will be no current in the operating coil at the time of normal working condition of the transformer. But if the major fault occurs inside the transformer, due to which the normal ratio of the transformer disturbs, then the secondary current of both CTs will not remain the same, and one resultant current will flow through the operating coil of the differential relay, which will actuate the relay and trip both the primary and secondary circuit breakers. This is about the differential protection of the transformer. If you found this video useful, then like, share and subscribe to my channel. Thank you.